Okay. So what I need is a new link. Okay, good. It's working. So I'm going to have to see what I can do. I don't know if I can see the chat, but I can see Slack. Oh, maybe I can see chat as well. Let me see if I can pop the chat out so I can see it more easily. And yeah, hopefully everybody can get onto this new live stream link and we can get started. Only 12 minutes late. And you can hear and you can see, I guess, what's on my screen here, which is good news. And yeah, first off, sorry about the technical problems. I tried maybe to outsmart myself by scheduling this live stream, and for some reason it didn't want to start. So yeah, sorry about that. And couple things maybe just want to start with. First off, welcome to the course. I think next week, this same day, so next week on Thursday, I'll be in Turku for the day, and so I guess we can avoid the live stream next week and do this kind of question and answer type of thing in person. But the idea for today is that I could possibly answer some questions and help you with anything about the course that either the lessons or the exercises that has been problematic or caused any kinds of trouble. Before we maybe do that, I wanted to just go over a couple things quickly. I don't want to take much time, especially since we've already used a fair amount of time with my technical problems, but I just wanted to hit a couple highlights here of the kind of course design, just to make sure that everybody understands how things work and kind of how I will expect communication to happen, so that if you're asking questions, they're going to a place where I see them and not someplace where they're overlooked for some period of time. So to start, there's this course environment. I guess you've probably already been to the course page and seen some of the stuff there. We've, I think, tried to do a pretty comprehensive job of documenting everything in the course, but I guess it's kind of a useful task to have you folks going through this without actually physically being present here while we're teaching the course, to help give us some idea, lovely, of how well we've done with documenting things. So for the course environment, of course, there's the web page, and that is the kind of central place where most of the information is going to go. And there are these things called Jupyter notebooks that we're going to be using in the course, and I think you've already started using those already from the first week in lesson number 1, and for the course in exercise number 1 as well. So these notebooks, the idea is that they mix a little bit of Python code with the ability to document things in a nice format using this Markdown language. So you're kind of learning 2 programming languages at once, but Markdown is relatively simple and it's quite nice. So within fields like data science, for example, these Jupyter notebooks are becoming quite popular because you can really describe what you're doing to your data as you're processing it, and then you can show the Python code that does the processing, and it's kind of a nice combination. I'd say it's actually better in many instances than having a separate code and separate documentation. Doesn't work in every case, but it's nice, especially I think as a new user to programming in Python. I guess you've also figured out some way to use these notebooks, whether it's on your own computer, if you've installed this Anaconda software. It includes a whole bunch of Python packages, including the Jupyter stuff, so that you can run Jupyter Lab on your own computer. It's a nice way to be able to continue things after you finish the course. If you get into the Python programming and want to be able to use it more, it's a bit easier than the cloud environment. But the cloud environment is also there, either using this binder service, which is probably the easiest way to get one of these notebooks live from the web page, is just to click the binder link. But it's not always working. It's a free cloud system, so you have to kind of take the downside that sometimes binder is not working or whatever. So the CSC notebooks you should also be able to use with your Hakka authentication, and I think actually I would slightly prefer CSC notebooks only because if your binder window goes to sleep or something like that, if after 10 minutes of inactivity you lose whatever you're working on, whereas the CSC notebook will stay open for as much as, I think it's a 6-hour time limit from when you start using it. Are there any questions about the kind of cloud environment or anything like that? Maybe, I don't know, yeah, either in chat or in Slack I can see both. But yeah, are there any questions about this? The unfortunate side of like doing this as a YouTube kind of live stream is you can see me and I can talk and whatever. You can see my screen. The video gets recorded, so you know, if somebody doesn't have the opportunity to watch it live, they can watch it later. But I can't really see you, and I can't get a good sense of any feedback other than through the chat or through Slack. So if there are questions, you know, put them there, and if there's any kind of delay, I may have to come back to some of the questions. Usually there's a little bit of a delay between what I'm streaming live and then what you're seeing and responding to. But yeah, I think the cloud computing environment is fairly transparent in a sense. And so that's nice. I guess this, if anybody's been using this CSC notebook system, I guess this joining code is still working. I hope that's the case. If it isn't, of course, that'd be good to let us know. If we need to create a new joining code or something like that, it can be done. And yeah, if I don't see anything in the chat or on Slack, then I'm just going to assume that it's working okay. The other kind of big piece of what we're learning, so we're learning this Python programming language, we're learning Markdown, but we're also learning a bit about this Git software and the GitHub web page. That's the kind of web interface to the software called Git. And it's a version control software that I think is described in a bit more detail in lesson 2. I guess perhaps you've read through some of the description there. To keep it kind of short and sweet, the idea is that it stores versions of files as you work on them. But for instance, with GitHub or Git in general, you have to tell it to store the files. It's not automatic. The important thing here is that when you're working on code, like when you're working with one of your Jupyter notebooks and you're changing things, every once in a while you'll have something where you had a working code and you break it. And the idea with Git is that you can always go back in time to the last times that you've committed your changes, which assumes that you are committing changes with some regular pattern or some regularity. So basically every time that you fix something in the code, let's say you're working on one of the lessons or working on one of the exercises rather, you fix one part of one problem, there's no harm in committing that change to Git at that point. It's actually better to commit more often than less often, because if you work on everything for 6 hours straight and commit it all at the end, you don't have any kind of increments in between the start of when you were working and that end point at 6 hours later, where maybe you want to go back to some intermediate version of the files that you had. So GitHub is basically, yeah, just a place where we can store files and keep track of them. Every time you change a file and commit the change to Git, it just puts that as the current version, and you can always go back and see the version history. That's pretty nice. Slack, I think, is fairly straightforward, and it seems like there's some 18 or 19, no, maybe 20 people now in the group that are actively using Slack, so that's good. I think if there's any questions about Slack, you know, you can communicate them somehow. I guess posting them in Slack would be the nicest place, because I like most of the kind of communication for the course to be in there. But yeah, I think it's pretty clear, and we'll have, I think we'll just kind of take advantage of the existing structure that's there for the Geo-Python course from this past fall. And that, you know, week 1, week 2, as we go through the course, you can always post questions in there. It gives a kind of clear notification that that a question has been asked. So that's the course environment, and I think I also briefly went over the idea behind version control and Git. If you're not really clear about any part of that stuff, again, it's a good time to put some questions into Slack or something like that, where I could possibly answer things. And with this Git system, essentially, you know, there's kind of an overview of how it works at the start of lesson 2. There's a bit of the kind of meeting Git, the syntax and the ideas here. I'll spend just a second on this because I think it's a useful thing to go through. Because sometimes Git, I mean, it's by this point for me, it's kind of become quite familiar, but when I was first using Git, it was a little bit unclear to me what these different levels were when working with the files, like when has it actually been saved to GitHub and things like that. So, you know, when you have one of the exercises, for example, it is an exercise that's stored in a Git repository on the website github.com. When you copy it down, when you basically clone the repository, to use the Git terminology, we clone it. It makes a copy of all the files that are in that repository, and that copy is itself a Git repository on your computer, on your local computer, or on the cloud computer you're using. So it basically copies the files to the whatever computer, cloud, or your own machine. And then you can start working with them. And when you want to make changes to the files, you might edit them, you know, by directly inside a Jupyter notebook, make some changes there, save it. And at that point, if you say, okay, well, I want to put my files into an updated version on github.com, the first step there is to take the files that you've modified and do a git add, and then you list the name of the file. So for instance, it's most often going to be git add and then the name of your Jupyter notebook. That will indicate to Git that you have designated some files that are ready to be saved as a new version. So they go into this thing called the staging area. And just adding the files doesn't actually save anything. It just designates that they will be saved when you do this next step, which is the Git Commit. And so commit is where you're actually saving, okay, I want to save the changes to the files, Git Commit, and then usually what you're going to do is give this -m, which is the flag to indicate you're going to give a commit message. And then you'll put something in quotation marks, which is the message that goes along with the changes you've made to the files. I've seen lots of activity already on the Geo-Python GitHub, so it seems like you guys are figuring this part out without too much trouble. But in case you're kind of wondering about the sort of overall flow, I think it's useful to consider. So you commit this with the message. The message then kind of goes along with those changes, and that is then an updated version of the files in the local repository. So on the cloud computer you're on, or on your local computer, you've now updated the files in that Git repository. Nothing happens on github.com until you do this git push. When you push the changes, it then copies them from your local machine up to github.com. And likewise, if you were editing on GitHub for some reason and you wanted to get the changes back to your own machine, you can do this git pull. So pushing is sending the files, pulling is taking them from the remote repository, so from GitHub down to your own machine. I think the more you go through this stuff, I think there's just a certain amount of weirdness at the beginning with Git, but as you go through dealing with things more, you'll become more familiar with how it works, and some of these things will start to make sense. You know, like maybe you want to add one file at a time before you commit. That's why there's a separate step to do this git add. You can, if you have many files you're working with, you might be picking through adding some of them. And then when you say, okay, all these changes go together, then you can do a git commit with that. I think that description beneath the figure here kind of covers most of the basic operations. Git can do a whole lot more than what we're going to do, but the main essence of Git is these sort of set of commands that are described here. So cloning, adding files, checking the status, commit, pull, and push. I guess I would probably say push and pull, since usually you want to, well, pull before you push is never a bad idea, because that way, if you've made changes on github.com, you also make sure that they get updated in your local repository before you push. If you don't do that, there's some not so nice things that can happen, like merge conflicts, and we'll hopefully avoid those. And one just quick word about this classroom for GitHub. The exercises for the class go through this thing called Classroom for GitHub. You've probably, well, I think everybody's been there and done that at this point. The kind of key idea here with the classroom system is we start out with some starting repository for the exercise, some example thing that you're going to work with. And we take that starting repository, and by using this classroom system, we make it so you click a button and it makes a personal copy of that exercise for you to work on, that you can see and that we can see. As the administrators for the course, we can see your exercise responses, but nobody else in the course should be able to do that. I think you've probably also encountered this little prompt about connecting your GitHub account with some name. I think maybe over the next week or something, I can put together a list of names for people so that you can stop getting that prompt. It's useful for when we start doing the grading for the exercises to have names connected to the GitHub repositories, because we don't always remember whose GitHub username goes with their actual name. So at this point, those were the things I wanted to go through for just course general stuff. Are there questions? I see somebody's typing in Slack. But yeah, this is maybe a good point for me to pause for a second and see if you have any questions. Okay, so one question about the git pull command. What could I do with it practically speaking? Okay. So the git pull command, I guess I could, well, let me see if this answers the question. But normally its main purpose is to take changes from some remote repository and make them in your local version on your own computer. So if you've been on github.com, well, actually I can show an example here. So for instance, I guess you can see my screen here. This is exercise number 1. I'm working in my private version of exercise number 1. In here, there's this readme.md file. It's a markdown file that describes what you're supposed to do in exercise 1. I guess you guys have seen that. And if I'm in here, I might add some note in here to myself. Note, get some eggs on the way home. I don't know why I'd put this in GitHub, but if I'm, don't have any place else to note that I need to get eggs on the way home, I could do that. And I could add my commit message here to say that made important note about eggs, and commit my changes. So I've made some modification to a file. Git doesn't care whether it's a Python file or a Markdown file or whatever. And just like I would normally commit from the command line, I can do the same operation within GitHub on the web page. I can see that I've made my change to the file here. But if I go over here, I've got another tab open in the browser where I don't have my notebook for exercise number 2. But if I look at the files here, or sorry, for exercise number 1, look at the files here for exercise number 1, I do have this readme.md file that I can see. It doesn't show up nicely formatted, but I can see the content of the file for exercise 1. And you can see the change I have locally, the change I've made on GitHub is not here locally. If I want to update this version of the repository that I'm working on the cloud computer, I'm here in exercise number 1 in that directory. So I'm just at the terminal, and if I can type the ls command, I can see here my readme.md file. If I type git status, okay, there's an IPython notebook checkpoint file here that's shown up that I can basically just ignore. That doesn't matter. But as far as the local version of the repository knows, I'm up to date with origin master because it's only considering what's available, the information it has on the computer that I'm working on. So on the cloud computer, it says everything seems to be up to date. But if I do the git pull command, and here's where I'm going to have a bit of trouble because I don't have my my GitHub password memorized, so just going to take a second to find my GitHub password here. So I've just copied that and pasted it in here. And when I do the git pull command, it now says, oh, there are some changes, and it pulls down the updated version of this readme.md file. And if I go into the editor, okay, I probably have to open the file again because it doesn't know that it has changed. But if I double click now on the readme.md file before, now I can see this note I had about eggs in the version of the readme.md file. Now, the reason that you should pull before you push is mainly that if you have made changes on github.com, then you need to pull those down to your local copy of the repository before you try to push things to GitHub, because sometimes if the same file has been modified, then there's this merge conflict where it doesn't necessarily know how to put the two versions of the files that have been modified together as one single file. So if you edit things on GitHub and you edit the same file on your local machine and you try to push, you'll get a conflict. And sometimes it can figure out, if you've modified different parts of the file, how to put them together, but sometimes it simply can't. And with the Jupyter notebooks, it doesn't usually do so well. So does that cover the question about this git pull command? And I guess maybe also the kind of idea why it always thinks it's up to date locally. It's mainly because it doesn't actually check on GitHub when you do the git status command. It only checks on your own computer or your cloud computer. Okay, so excellent. Interaction. Question and answer. Okay. Yeah, I think maybe I could ask, are there other questions other things that that have been confusing. It seems like everyone has been kind of figuring out the exercise workflow at least. You know, I could go through some of these basic things in Python, but I'm not so sure that that's necessary. Maybe it's better if you have you know, some specific questions that I could try to answer those. And I can also maybe talk a little bit about some of these things if there's some time next week when I'm there. But yeah, I mean, there's things like, I'll tell you right now that this idea of lists, the concept is really simple in terms of like the essence of what a list is. I mean, you can think of many different types of things that work in a similar way to a Python list. But every time we've taught this Geo-Python course, the kind of connection between list, the items that are in the list, and this thing called an index value, that's a little bit of an issue that seems to be maybe just conceptually a little bit tricky to understand. So if you want to hear a little bit about lists, I can talk a little bit about lists. Some of the other stuff, like from the very first week's lesson, there was a little bit about data types, and I think at least those kind of 4 main data types, this integers, floating point numbers, booleans, and character strings. I think those are, you know, seeing how they're different from one another. I at least have the impression in the, you know, based on past versions of the course, that that's not been too terribly difficult. But yeah, I mean, if you have questions, feel free to put them into Slack. Otherwise, maybe I'll say a couple words about lists, just because I would anticipate that this will be one of the things that takes a little while to understand. So on the version of the lesson for the course, for this lesson number 2 about making lists, you know, there was a list that we defined here, and there's the syntax that you use these kind of square brackets, and then you put some stuff inside separated by commas. And so in this case, it was like the names of these observation stations from the Finnish Meteorological Institute that we put into a list called station names. And once you had done that, you know, you could do things like check what the data type is, and you see that the type is a list, and you can check the you know, the values within the list and things like that. And for the list, you know, here you can look at it and you can see, okay, well, there's 4 items in the list. And this idea of an index value is essentially the address or the location where you would find those different items. And so in order, like with our list here, if I just run this cell to save the list to memory, then I can go here and do something like station names 1. Don't even need to print it, but I can just run that. And you see a useful thing here. And the first is that this number can be used to refer to a location within a list. But also you see that there's an indexing standard in Python and many other programming languages that things in lists and values that are ordered start with 0 rather than starting with number 1. So the first thing in the list here you might think would be station names 1. That's actually going to give you the second item in the list. Station names 0 would give you the first item in the list, because the index value or the address for each of those is 0, 1, 2, and 3. So you know, this number is useful in the sense that, like, if you don't know what's in the list but you know how long it is, there's Python commands that can tell us how long something is if it's a list, that you can then go through, and you'll see in I think already in lesson 3 that you can go through each of those values in the list and print out what the value is. We came up with this perhaps useful analogy and kind of poorly depicted vending machine called Bill. you know, it's supposed to be some kind of dollar bill y'all joke that you put your money in there. Anyway, the idea with bill is that it basically works like a Python list. A vending machine, it's a pretty good example of how a Python list works. You put your money in, you know what you want, like say, you know, you've got some vending machine where you actually want to buy a cheeseburger from it. You put your money in, you say, okay, well, I want that cheeseburger. That's the item in the list, and the way that you access that item is to use its index. In this case, it's at position number 2 or index number 2, so you put in your money, you push button 2, and with that index, then you get back the cheeseburger that drops out of the slot, and then you make a decision at that point about whether you want to risk eating a cheeseburger out of a vending machine. But that's the kind of idea here with this analogy for how lists work. When you get stuck with this stuff later in the course and you're having to deal with index values, if you can think back to how vending machines work, that will hopefully help you figure out the difference between the items in the list and then the index, which is their location or their address. So, yeah, that's just a quick overview. There's more stuff that happens on like later in the lesson about modifying lists, adding values, reversing them, making changes to the list, sorting things. We don't do a whole lot of sorting. I think there are some lessons where you might add things to a list if you want to, because one of the useful things you can do in Python is create something that's an empty list and then start using this this append method, this dot append thing to add values to the list. So I guess there's an example of using append here. I don't actually remember what was in the lesson, but if you had something like a list of dogs, you could start out with an empty list, so it's just dogs equals, and then you define it as a Python list with 2 square brackets. Nothing else goes there. And if you wanted to add then some type of dog to your list, you could do dogs.append, and then in quotation marks, because we're going to give it a proper name for the dog, you could put, Rover or whatever, some dog name. I don't know what the kind of generic Finnish dog name is. Rover is a pretty dated one even for like American dog names, but you could put in some name of a dog, and then if you looked at what's in the list dogs, you would see that Rover is there. And you can use this dot append then to continue to add more and more things to lists. So yeah, that's just a few words about lists. I see I've been talking maybe more than I had expected, but at least this issue with lists and list index values is something that we'll come back to several times, and seems to be something that's a bit challenging for, I don't know. I get the sense that it's like, it just takes a little while before it clicks, and then you're like, oh, now I get it. And from then on, your life is wonderful. So yeah, are there other questions, other issues about the course? I mean, this can kind of be, you can put anything in chat or on Slack, any kind of things here. Maybe for the future weeks, I'll make our own separate little channel just so that we can have some chat in there. But this in the general channel is perfectly fine. So, okay, we got another question. Have a list of words with a string data type. Is it possible to change the type of words into integer in a list? So, yeah, I mean, it's possible. So let's go through an example maybe. What I'll do, I think, is I'll maybe make a new notebook real quick, just so that I can show you this. So let's make a list and put a few words in there. So we could have, let's see, how about a list of cars? And we'll add in here, how about, I don't know, Ford and Mercedes and BMW, and maybe one more. We'll put in Audi to go with the theme of German, mostly German cars. So here's a list of 4 different cars, and there's, these are words, and so converting these, directly to an integer themselves wouldn't necessarily make any sense. But let's say for some reason, some tech company comes out with a technologically advanced car called the 2 or whatever, and we wanted to put in there, this oops, I've overwritten my list. Okay, run this first cell again to recreate my list, and what I meant to do here was to append 2. So that's our, cool new tech car. So you can see then, if I look at this list called cars, I've got Ford, Mercedes, BMW, Audi, and 2. Now, 2 in this case, since I've entered it with quotation marks around it, is a value that is stored as a character string. Even though it's a number, it's stored as a character string in here. Now, if I wanted to change the data type of that value to be just the number 2, I can do that. And there's 2 reasons why. One is that a Python list does not need to have data of the same type in it. You could actually have lists with essentially any different kind of data type that you want stored within the same list. It's just a Python list. It's kind of like a garbage can where you can put in anything you want, or maybe a grocery cart's a kind of nicer analogy. You can put in, fruit or meat or whatever. But here in our cars list, there's no reason you couldn't have the names of these 4 cars as character strings. Those can't easily be represented as numbers. But then if you wanted to have this number 2 actually be the number, you could do that. The way to do that is going to be to use the index. So first off, we have to figure out where it is that we want to make the change in our list. And if you remember that the Python index starts at 0, so we're looking at 0, 1, 2, 3, and here at index number 4, we should have our number 2. So that's our cars 4, and when we just run the cell, it says, okay, yep, there's our number 2. Now, what you can do is say cars 4 equals the integer of cars 4. And what this is going to do is it's going to take the value that's here in cars 4. It's a number value, so it can do this conversion. It's going to convert it to an integer using this int function, and it's going to store its value in the place where we had the string number 2 in quotation marks before. So I run that, and then if I go back here and just do cars 4 and run that cell, then I can see that I have the number 2. Or if I want to see the whole list of cars, I can run this cell, and now I see Ford, Mercedes, BMW, and Audi, all with quotation marks indicating their character strings, and then the number 2. So that's totally fine. If I tried to do this same conversion, for instance, to Audi, I'm going to have a problem, and I'm going to get some kind of error here. In this case, it's a value error that says, basically, I can't convert the word Audi with a base 10 number to an integer. And unless we give Python some more instructions about how to handle converting letters to numbers, that's kind of an expected error message to see. But yeah, I mean, there's this kind of conversion of items within a list. It's not a problem. Lists are very flexible, and you could if you said like, there's too many German cars in this list, I don't want to have any, so many German cars, let's get rid of Audi. You could put in, something else in place in position, index 3 in the list. You could put in, Saab or whatever. Some, I don't know whether a Swedish choice is, any more appealing. But the point here is that you can modify the things in the list in any way that you like. It's a very flexible structure. Later in the course, we'll deal with some other data types that look a bit like lists that are called arrays, and arrays have a restriction that they have to have the same kind of data within them. In a Python list, you can actually have other lists within a list and things like that. So it's quite relaxed in terms of what you can do with Python lists. So yeah, other questions or issues? I think we're kind of running close to the time when we had maybe planned to stop, but I'm okay to stick around for a little bit since I managed to screw things up and start us a bit late. I could see maybe another question coming here in Slack, or at least something. Okay, so a question about Git here now. So what's the difference between git push origin master and git push? Well, I don't know if I have a very clear explanation for this. I mean, git push origin master is essentially a more verbose or more sort of detailed way of doing a git push operation. So the way that Git works, and something we're not really going to get into, is you can have different things called branches, which are essentially like within a Git repository. You can sort of split files off into a separate grouping of files called the branch. I don't think I have a very succinct way to explain exactly what a branch is, but you could think about it this way: from the perspective of like someone who writes software for their job or something like that, the master branch is often used as like the working version of the code. So like the things that go into the master branch are like the we know this works, so that's what's in master. And often you'll have something called like a develop branch or some other branch where you're actively making changes, and some of the changes might break the code. So the files themselves, like if you had a simple Python project, you might have the same source files in both places, but you only update the master branch when you know that it worked properly. The develop branch you might be actively working on other times, and there's we don't need to get into how to change branches and stuff like that at the moment because it'll probably get a bit confusing. But the concept here with like git push origin master, origin is usually the reference to the files that you're working on in the repository that you're working in. You can actually rename that if you wanted to, but don't. It's not going to make life better for you. But when you do the git push command, you're saying from where and then where is it going. So you're saying I want to push my changes from the origin to the branch called master in this case. For us, we're only going to ever work with one branch, so that's always going to be the branch called master. In most cases, if you just type git push, Git assumes that whatever you want to push is from your local branch to the branch of the same name on the remote server where you're working. So if you've cloned something from GitHub, then Git knows that there is a master branch in the repository on GitHub where you cloned your files. And so you can just type git push, and it will then update from the copy you have on your computer, the master branch on github.com. If you said I want to update, from my master branch on my local machine to the develop branch on github.com, then you could do something like git push origin develop, and that would then say, okay, I want to go to a different branch name. But But yeah, the origin here in, I guess you can't see Slack, but I guess, well, if I put it down here, maybe you can see what I'm talking about. So, you know, the origin here is referring to the source of the files, which is usually the local branch name, although you could have, or not local branch name, but the local, I can't remember actually what they call it. But anyway, it's the local files on your machine, and then this master is the name of the branch that you want to update. So again, git push is going to suffice in most cases for our purposes. So, good question though. That's a yeah, I think something that's good to understand. There's a lot more about Git that we could go into, but I'm trying not to trigger a revolt at this stage. So, yeah, I don't know. Other questions or other issues? Have there been any kind of big problems or anything like that? Is everybody okay with this Slack system? I think it's a nice way to communicate. Kind of keeps everything grouped together so it doesn't get lost in my email, which is far too common occurrence. Maybe got another question here. Let's see. Okay, that seems like good. Let's see. Where did that go? So I see a lot of exercise 2s that are active, so that's good. Seems like you guys are figuring that out. Gets a little bit hard to keep track of everything because now there's 144 repositories to come up with exercise 2, but yeah, it seems like that part's okay. Looked like there was maybe one more person typing in Slack, so we'll hold off for just a second here. Okay, notice that sometimes JupyterLab denies access to some repository, even if one has typed the repository before. Okay. Denies access to some repository. I'm not sure. So maybe just for some clarification here about this denial of access for JupyterLab. I mean, is it something where, like, if you're in JupyterLab and you go here and try to open a file, that it's a problem, or is it something about Git where you're trying to save changes with Git or something like that? Denies access. Like if you're maybe cloning, I don't, yeah, maybe I'll wait here a second and see what the question is. Committing or adding files. Huh. I mean, I would say it's possible if you've cloned the exercise to like the main repository for the course. Like we have had in the past people who have cloned the course repository, and then if you try to push changes there, you will get rejected because you're not on the list of people that can make changes to the course files. If you are certain that you've used the GitHub Classroom link to create your own private version of the repository, I can't think of any reason why you would be denied access, but if you maybe copy and paste the error message into Slack next time it happens, I can try and see. I mean, it should, I think, I assume nobody's using like this two-factor authentication, which, you know, you have to use like your phone to sometimes like log into your GitHub account. That can sometimes cause problems that if you try to push changes. Changing directories, yeah, if you're not in the right directory and you want to push changes, that it's possible. You know, some of these things with Git just take kind of going through by hand, but you know, if I'm here in the exercise 1 repository, I could add files here. So like I could do, I actually don't want to necessarily do this because I'm going to try to, it's going to ask me for my password that I can never remember. But I could do like a git add this untitled.ipynb, this IPython notebook that I just made. And I can even commit that with some nice message about like test notebook. Okay, it's not a very good commit message, but I can commit it. Okay, I haven't done my configuration, so maybe I can't commit. The point is, though, that if I tried to do something like using git out here, like git status, and I'm not in the right directory, okay, well, actually, this is a little bit more complicated because I'm in a directory where it is already a git repository. But if I'm here in the work directory and I do git status, you know, it's going to tell me it's not a git repository. If I try to git push or something like that, it's going to complain. Usually you'll get some message though that tells you like it's can't find the .git directory. This is a hidden directory that identifies a directory as a git repository. But yeah, I mean, these things, little things like this, not changing into the right directories and things like that. So lazy question, is there a way to open an IPython notebook from the terminal? Are you opening it on your own computer or on a cloud computer? I think is a important question there. I mean, once you're in Jupyter Lab, I think the easiest way in Binder. I don't know, actually. I mean, normally I've just used this little navigator thing over on the left, and I'm really not someone who's big on like mouse pointing and clicking. I prefer to kind of type things. But is there an open command that works? No. So on Mac OS, you can usually use this open command. We've already got Jupyter Lab running, so I don't think it's going to be happy if we try to do like Jupyter Notebook and then the exercise name. I mean, it's going to try and launch Jupyter Notebook, and I don't think that's what we want to do. That's a good question. I can see if I can find anything about it. It wouldn't surprise me if there's some kind of shortcut to open this file from a terminal within Jupyter Lab, but I will say that Jupyter Lab is something that can run on Mac OS and Linux and Windows, and that these terminals that it uses are all kind of the terminal from the machine where it's running. So like this is a Linux terminal, and there's a different one, of course, for Windows and for Mac OS. So it might be actually that it's doing more like kind of system stuff, and it doesn't actually know, like from within the terminal, it might not know that you're actually in a Jupyter Lab session. So maybe there is no shortcut, but yeah, I can take a look and see if I see anything useful. I'll post back in in Slack here, and you know, we can keep in touch about that. But yeah, I mean, otherwise, like I said, I kind of wanted to highlight a couple things. Are there other? Okay, yeah, so couldn't find anything on Google. Yeah, it wouldn't surprise me, actually, now that I think about it, if there's not a shortcut to do this, because the terminal is not necessarily aware that you're in JupyterLab. Now, if I'm running on my own computer, which is generally what I do, I mean, if I'm working on Jupyter stuff for my own interest, I don't log onto the CSC and use a Jupyter notebook there, but I've run on my own machine. I actually don't know whether I could do this open command and have that work either, because I don't know if macOS knows to connect this IPython notebook file or Jupyter notebook file with JupyterLab. So it may be that you just have to navigate and click on stuff in here, which, you know, fortunately the web interface for JupyterLab is pretty decent, and it's I think it's kind of rapidly evolving. Even, well, it was about a year ago, or just over a year ago, that the JupyterLab project went public and was launched. So Jupyter notebooks have been around for a while, but this JupyterLab is somewhat of a new thing, and it's still being developed quite a bit. So yeah, are there any other questions? I have no idea how much lag time there is between what I say and what you guys hear, but it seems like it's not so bad. So I'll wait a few seconds. If there aren't any big questions, then you know, you're always welcome to ask questions in Slack. I can't guarantee the most rapid response, but I'll try to answer things there if they come up. And otherwise, I'll be there for the day next week and can also answer some questions there. And I think, you know, as much as this course is available online and everything is kind of supposed to be there, and, you know, you just have to follow the web page and you'll learn Python in no time. There's certainly an element of, in my view, of benefiting from being in a classroom, whether it's a kind of virtual classroom like this kind of live stream thing, or sitting down together in the same room. I think that's still an important part of this, and in terms of like trying to develop a sense of your own confidence that you can do things in Python. You know, I'm hoping that, like, at least it'll be one day of the course that we get to kind of be together in the same place, but hopefully that'll be useful next week, because I think everybody's capable of doing this stuff in Python. It just takes a little bit of time, and it's actually, in some ways, it's really simple, and in some ways, the things that are simple are actually more complicated than you might think. And I've noticed this with logic for the programming, for instance. It seems really simple, but in fact, it's actually more complicated than you might think. So, yeah, any last questions or concerns? If not, like I said, you can put other questions into Slack for the future, and we'll continue next week, and for the weeks that follow, I think we can kind of keep doing this live stream thing if it seems to work okay. I'll get some feedback about that next week. But if the live stream thing seems all right, we'll maybe continue with that. If it seems like it's kind of not that useful, or it's too hard to ask questions, then we can always also try something else like Skype. But yeah, otherwise, I think that's kind of the extent of what I had planned to cover. And I'll just check in here on Slack. And yeah, if there's nothing else, well, it seems one person typing in Slack, so I'll hold on for a second. Okay, seems like YouTube worked pretty well. That's good news. On the second try, yes indeed. I'll see if I can figure that out. I outsmarted myself with this scheduled live stream. Still don't know why that didn't work. And okay, no big lag. Okay, yeah, I tried to set it so it wouldn't be a major delay. It's there's always a few seconds, I think, so we can try this again. Okay, that sounds good to me. So yeah, I'm happy to give this another shot, and like I said, post questions in Slack if you have them, and we will continue, hopefully face to face, next week. So, all right. I think I'm going to see if I can shut this stream down. So, yeah, thanks, and we'll see you guys next week.